Hey everyone, and welcome to This Explainer. I am absolutely thrilled to have you here today. If you're a grade 10 science student tackling the Math-Tag curriculum, or frankly, you're just a curious mind ready to figure out the invisible mechanics of the world around us, you are in the exact right place. Think of me as your master teacher for the next few minutes. We're going to completely transform the way you look at everyday life by diving into the wild and fascinating realm of chemical reactions.
But before we get into the heavy science, I want you to think about this everyday mystery. Where does a tiny pechay seedling, or any plant in a school garden for that matter, get the actual physical stuff to grow into a massive plant if it's essentially only getting water and sunlight? It kind of seems like magic, right? Well, it's not. It's chemistry. And to solve this mystery, we've got to learn how to read the secret language of the universe.
All right, let's dive into this. Here is our game plan for today's masterclass. We'll start with the language of chemistry, then we'll uncover the golden rule, and finally, we'll break down the 5 reaction types.
So, Section 1, the language of chemistry. Look, just like any language you learn, chemistry has its own alphabet, its own grammar, and its own unique way of putting sentences together. If you can read the sentence, you can understand the reaction.
What's really cool is how simple the basic sentence structure actually is. Every chemical equation has a before and an after. On the left side, we have our reactants. Those are the substances hanging around before anything happens. On the right side, we have our products, which are the brand new substances formed after the reaction. And right in the middle, there's an arrow. Now that arrow doesn't mean equals. It means produces, forms, or yields.
Now to actually read these equations, we need to nail down some vocabulary. An atom is basically your smallest building block. An element is a pure substance made of just one kind of atom, like carbon. And a compound? That's when 2 or more different elements chemically combined, like H2O. But let's really focus on these last 2. The coefficient is the big number written before a formula telling us how many molecules we're dealing with, and the subscript, that's the tiny number hanging out at the lower right of a symbol. Listen to me very closely on this one. You can never, ever touch a subscript when balancing equations. Changing it literally changes the identity of the substance. I mean, H2O is the water you drink, but change that subscript to H2O2, suddenly you're drinking toxic hydrogen peroxide. So yeah, it's a massive rule.
And speaking of massive rules, let's take a breath and move right into Section 2, the golden rule. This is the absolute, unbreakable law of the chemical universe.
Matter is not created nor destroyed during a chemical reaction. Atoms are just rearranged. That is the law of conservation of mass, first figured out by the brilliant Antoine Lavoisier back in the 18th century. In chemistry, nothing just magically pops into existence and nothing vanishes into thin air. The atoms you start with are the exact same atoms you end with. They just swap partners. They're just reorganized.
So how does this answer our plant mystery from earlier? Well, during photosynthesis, plants take in carbon dioxide from the air. In that chemical equation, there are exactly 6 carbon atoms in the carbon dioxide reactants. Because matter cannot be destroyed, those exact 6 carbon atoms are perfectly conserved, rearranged, and built into the glucose product. And that glucose, that is the actual physical material making the plant grow. It is quite literally pulling its own mass out of thin air. How amazing is that?
All right, moving to Section 3, the 5 reaction types. Once you realize atoms are just rearranging themselves, you start to notice they do it in beautifully predictable ways. It's almost like the universe has its own filing system. Let's look at the distinct personalities of these reactions.
Archetype number 1 is the combination reaction. It's exactly what it sounds like. 2 or more smaller substances join forces to form just one single brand new substance. If we want to visualize this mathematically, it's super clean. Substance A reacts with substance B and boom, it produces a single compound, AB. 2 things become one.
Let's ground this in reality for a second. If you leave your bike out in the rain, the iron in the metal, that's our substance A, combines with the oxygen in the air, our substance B. They join together to produce a completely new substance, iron oxide, or, as you probably know it, rust.
Okay, our second type is the decomposition reaction. This is the exact opposite of what we just talked about. You can think of this as the messy breakup of a chemical marriage. Here, one single compound shatters into 2 or more simpler substances. Looking at the before and after, we start with one compound, AB, on the reactant side. It breaks apart, and the products are multiple, simpler things, A plus B.
And honestly, you see this happening in your own kitchen all the time. When you leave food in the fridge way too long and it spoils, getting that funky smell and texture. That is a decomposition reaction, breaking down complex food molecules. Another great example is hydrogen peroxide, that stuff in the brown bottle. Over time, it just naturally breaks down into regular water and oxygen gas.
Let's keep moving to type 3, the single replacement reaction. I always playfully compare this one to someone aggressively stealing a dance partner on the dance floor. It happens when one single element replaces another element inside a compound.
Here's how the mechanics work. We have a single element, A, reacting with a compound, BC. Element A kicks out element B, taking its place to form a brand new pairing, AC, and poor element B left all alone as a single product.
Now, contrast that with our fourth type, the double replacement reaction. In this one, nobody ends up alone. Instead of one element getting kicked to the curb, two entirely different compounds are just swapping partners to form two completely new compounds. Check out how clean this swap is. Compound AB reacts with compound CD. A from the first compound swaps over and pairs up with D, while C pairs up with B. It is a perfectly balanced mutual exchange.
And look, these replacement reactions aren't just abstract ideas on a whiteboard. They are running the real world. A single replacement reaction is actively happening inside the lithium-ion battery of the device you're probably using right now. Meanwhile, double replacement reactions are doing the heavy lifting in large-scale water treatment plants, safely swapping out toxic heavy metals so you have clean water to drink.
All right, finally, we hit our fifth and definitely most energetic archetype, the combustion reaction. The absolute, mandatory key ingredient here is oxygen. A combustion reaction happens when a substance reacts with oxygen, burns and produces carbon dioxide, water, and energy in the form of heat and light. So whenever fuel reacts with oxygen, it's following these strict rules. Even a simple campfire, burning wood, or just the wax of a candle, that's combustion. And it might blow your mind a little bit, but alongside the heat, light, and carbon dioxide, that blazing fire is actually producing water, just as water vapor. It's all just atoms perfectly rearranging themselves.
So we've covered the language, the golden rule of conservation, and those 5 main reaction types. Now I have a challenge for you. Take the lens of a master chemist and apply everything we just talked about in this explainer to the room you're sitting in. Look around right now. What is one chemical reaction happening at this exact second? Is something rusting? Is a battery powering a screen? Chemistry isn't locked away in some textbook. It is happening everywhere, all the time. Keep exploring, keep asking questions, and I'll see you in the next explainer.